In this video I'll go over some examples of past paper questions that would be on the topic of types of chemical bond. First question, which line in the table is correct for the polar covalent bond in hydrogen chloride? And they've got position of bonding electrons and they've got the dipole notation. When you're answering multi-choice questions at all, you should always try and answer yourself and then look at the suggestions. So let's have a think about hydrogen chloride ourselves. If we look up the electronegativity values, we'll find that hydrogen is 2.2 and chlorine is 3.0. That tells us that chlorine is a greater attraction for the bonding electrons compared to hydrogen, and so chlorine will be a little bit negative. Compared to hydrogen, that's a little bit positive. If we're thinking about the position of the electrons, well, chlorine's a little bit negative because the electrons are closer to chlorine in that bond. So now that we've figured that out, we just need to compare what we've got to what is in the options here. If we look at the dipole notation, hydrogen is slightly positive. That allows us to rule out the two bottom ones straight away. Then looking at the position of the electrons, we've put our electrons closer to chlorine because chlorine has a higher electronegativity, so B is wrong as well, which leaves us with A being the answer. Example 2. Which of the following compounds has the greatest ionic character? So we have to go back to our spectrum here, our bonding continuum. We can describe bonds as being greater ionic character when there's a big difference in electronegativity, and as the difference in electronegativity between two atoms gets smaller, we're getting less ionic character in the bond and tending towards the polar covalent bond, so more uneven sharing rather than the electron transfer. The easiest way to tackle this type of question is just look up the electronegativity values and see which has the biggest difference, which pair has the biggest difference. And looking at those values, we can see the biggest difference there is between cesium fluoride, so that gives us our answer as being A. Example 3 is very similar to the previous example. This time, though, they're looking for the least polar, so they're looking for the smallest difference in electronegativity. So we'll just get our electronegativity values again and see what the differences are. So the least polar is the one with the smallest difference in electronegativity, and that's the carbon and iodine bond. So again, A is our answer. Example 4. Elements in the third period of the periodic table form chlorides. The structures of 3 of these chlorides are shown. Circle the structure of the molecule that contains bonds with the lowest polarity. And having a look there, we are comparing a few different elements to chlorine. So let's get our electronegativity values down. So the lowest polarity of bonds are going to be the ones with the smallest difference in electronegativity. Comparing the values there, we see it's going to be sulfur with chlorine. So this answer here is correct. Our final example is hydrogen will form a non-polar covalent bond with an element that has an electronegativity value of what? So non-polar is just a different way of saying a pure covalent bond. And with a pure covalent bond, the electrons are shared equally between the two atoms that are bonding. For this to happen, they must have the same electronegativity. So we're looking for something that has the same electronegativity as hydrogen. If we go to our data booklet and we look up hydrogen, we find the electronegativity is 2.2. So that gives us an answer of C.